Alrighty, everyone. This will be Homework 9 lecture for the Math 1111 course. We have a word problem. Philippe and his wife are each starting a savings plan. Philippe will initially set aside $125 and then add $20.55 every week to the savings. The amount A in dollars saved this way is given by the function A equals 125 plus 20.55 N, where N is the number of weeks he has been saving. His wife will not set an initial amount aside, but will add $75.65 to the savings every week. The amount B in dollars saved using this plan is given by the function B equals 75.65 N. Let T be total amount in dollars saved using both plans combined. Write an equation relating T to N. Simplify your answer as much as possible. This is actually easier than it sounds. Okay, so the first one we have, Philippe and his wife are saving. The amount A in dollars saved. N is the number of weeks that he's been saving. B in dollars again, saved. All right, N is still the number of weeks. T is going to be the total. T is the total amount in dollars saved. So both folks are putting money into their account. So T is equaling the amount Philippe is saving plus the amount that his wife is saving. So you're simply adding 125 plus 20.55 N. You're adding that amount, Philippe's amount, plus his wife's amount, which is just 75.65 N. We combine like terms, 20.55 N and 75.65 N. We get 125 plus, let's see here, I'll do this backwards. 5 is 10, that's 12, carry your 1, that's 6. Looks like it's going to be, if I did my math correctly, 125 plus 96.20 N. You guys can check my arithmetic and let me know if that's correct or not. Now the next part is going to be exciting and fun. It's called the difference quotient. When you get to calculus, you're going to have to be able to do a difference quotient. All right? There's no getting around the difference quotient. So, what I'd like to show you is where the difference quotient comes from. So in order to do that, I need to come over here and get some extra paper. There's no telling what I've got written there. Let's go back. I want the 1111 notes. There we go. All right, so a new note. This is great. Maybe you remember the slope formula. Why is that not black? Oh, all right. Don't know what I was doing. All right, that's probably drawing. Remember the slope formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, then somebody got really exciting and they said, let's let y sub 1 equal f of x sub 1 and y sub 2 equals f of x sub 2. Remember, we switched to function notation. So this then becomes, let's see, there we go. That's better. This then becomes f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. All right. Then someone said, let's let x sub 2 minus x sub 1 equal h. That'll just be the difference. And we can solve for x sub 2 by adding x sub 1 to both sides and resubstituting back in. So now x sub 2 is x sub 1 plus h minus f of x sub 1. And our difference on the bottom is now h. Because the variables are the same, we no longer need the little 1 as a subscript. And that creates the difference quotient. Calculus is just all about slope. We learn faster and better ways to find the slope in calculus. Difference quotient helps us do that. As you can see, it is our average rate of change, which is the slope. You link it with some fun stuff in calculus, and it turns out to be more fun stuff. Instantaneous. But anyways, this is the average rate of change. All right, so what do? Well, we learned back there somewhere that when we're dealing with a function, what we have here is we stick it in for x. So the first part, f of x plus h, is f of x plus h. So 5 times x plus h squared minus 8. I like to put it in brackets so I can recognize what it is. Then we're going to subtract the original function, which is 5x squared minus 8. Now all we have to do is the math. All right. So this first piece is going to be 5x plus h squared, and you can FOIL that out and check it all you want. This becomes x squared plus 2xh plus h squared, then minus 8. Then we can distribute the negative and get, I'll tell you what, let me erase that. And let me erase this, because I forgot something very important. What did I forget? This thing is all over h, right? This is our difference quotient. That's what I forgot. All right. So let's move on here. So equals, same thing it was a second ago, I just had to erase it all. 2x squared plus 2xh plus h squared, then minus 8. Then distribute the negative through, minus 5. I'm trying to find room to write, because I want to kind of leave it on this. Try again. It's going to be long. Start over here. 5, here we go, x squared plus 2xh plus h squared minus the 8. Distribute the negative, minus 5x squared plus 8 all over h. All right, equals. Now we can distribute the 5. You get 5x squared plus 2xh plus h squared minus 8 minus 5x squared plus 8 all over h. Then 5x squared will cancel with 5x squared. Minus 8 plus 8 goes away. And all we have on the top now are h terms. 2xh squared, 2xh plus h squared over h. Well, you know when there's something in common, you can factor that common out. Common h comes out. We get 2x plus h over h. And then those h's cancel, and we get 2x plus h. I call this pure algebra. It's just nuts. But here we go. All that is that problem there. And that, 2x plus h, is our answer. And that will give us the average slope. In calculus, we learn how to use that with a limit and get the instantaneous slope at a point. We'll save that for calculus, shall we? Number 3. Suppose the functions r and s are defined for all real numbers x as follows. R of x equals x minus 4, and s of x equals 3x squared. They want us to find the sum of the functions, the product of the functions, and the difference of the functions at -3, at x equals -3. All right, so to add them up, we just take the r function, x minus 4, and add that to 3x squared. We get 3x squared plus x minus 4. They like it in descending order, remember? Let's go ahead and make this one red. The product is simply x minus 4 times 3x squared. That'll work. You can also write it 3x squared times x minus 4, and you can also distribute the 3x squared out. The last one here, subtraction, the difference between r and s when x is -3, there's two ways to do that. We got x minus 4 minus 3x squared. But remember, x is -3. So we can replace x with -3. All right, and that gives us -7 minus 3 times 9, which is -7 minus 27, which is -34. Isn't that exciting? It's called the algebra of functions. You can add, subtract, multiply, and divide with the algebra of functions. Number 4. Suppose that the functions h and g are defined as follows. H of x equals 3x squared minus 5, and g of x equals -6x plus 2. We want to find the quotient h divided by g when x is 4. That's our first step. And then we want to find the values that are not in the domain of h over g, right? This means g can't be 0, right? And again, if there's more than one value, we'll separate them. So let's do a first. So a, we want to find h divided by g, the functions, evaluated when x is 4. So h is 3x squared minus 5 over negative 6x plus 2. All right. Well, I guess the first thing we need to do is do this when this is an x. Now we can do it when it's a 4. Make sure our notation is correct. So 3 times 4 squared minus 5 over negative 6 times 4 plus 2. So it's like we were doing before. We put the numbers in where x is, but we have an extra step. We're actually doing some kind of algebra, in this case division, with our functions. Alrighty, so mathematically this is going to be 4 squared is 16, so 3 times 16 minus 5. Negative 6 times 4 is negative 24 plus 2. Yeah, I'm going to come back a little further with that. And that's going to be 3 times 16, I think, is 48. 48 minus 5 over negative 22. Bring the negative out front. 22 stays in the denominator. 48 minus 5 is 43. I don't believe that simplifies. You can let me know if it does. B says what is not in the domain of x, h over g. So B, not in the domain. We already know that h over g is 3x squared minus 5 over negative 6x plus 2. Not in the domain, we know we're just taking the denominator and setting it not equal to 0, right? So we have negative 6x plus 2 not equal to 0. Subtract the 2 from both sides. Divide by your negative 6. Negative 2 over negative 6 is 1/3. So 1/3 is not in the domain of h over g. Number 5. Wonderful. You're going to love this. Okay, we have the functions f and g. F of x equals numerator of x, denominator x minus 3. G is the numerator x plus 1, denominator x minus 3. We want to find, lovely enough, the quotient f divided by g. Then we want to give the domain an interval or a union of intervals. So we have to remember that our denominators, these two denominators are the same, so it's not equal to 0. So in our original problem, x cannot be 3, right? And then f over g is going to be x over x minus 3 over x plus 1 over x minus 3. But we remember what to do with those, right? So that's going to be x over x minus 3 times x minus 3 over x plus 1. Our x minus 3's cancel, and we get x over x plus 1. But we know that this cannot be 0, or x plus 1. So we also know that x cannot be a negative 1. So our domain excludes these two values. Goes from negative infinity to negative 1. Union negative 1 to 3. Union 3 to infinity. So that's our domain. All right, and that is our f over g. Okay. Oh, we got some more fun stuff going on here. We got more functions. Yay, functions keep coming forever and ever and ever. For question number 6, we suppose that the functions f and g are defined as follows. F of x equals negative 2x plus 1. G of x equals the square root of 5x minus 3. This time we want to find the difference and the product. And we also want to give their domains and interval notation. Alrighty. So in our case, f minus g is going to be the negative 2x plus 1 minus the square root of 5x minus 3. That's as far as we can go. The domain, you might remember the domain of radicals, right, has to be greater than or equal to 0. So you can do the algebra on this, and this says that x is greater than or equal to 3/5. So our domain is from negative infinity to, no, it's not. Our domain is from 3/5 to infinity. 3/5 is enclosed. Domain is not. That's that piece. Well, let's see that better. So that's that answer. All right. This one, f times g, is simply negative 2x plus 1 times the square root of 5x minus 3. And the domain is the same thing. We're going from 3/5 to infinity. It's a comma. Does that look like a comma? There we go. Yay. Notice we haven't actually done any real arithmetic. Question 7. Well, you're going to love this. We're getting into composite functions. The functions q and r are defined as follows. Q of x equals 2x minus 2. R of x equals negative 2x squared plus 2. We want to find the value of q of r of 4. So the first thing we're going to do is plug 4 into the r and then plug r into the q. So that we start with r. R of 4 is where we start. So that's negative 2 times 4 squared plus 2. And we do the arithmetic. Might have to do arithmetic a little longer. That's negative 2 times 16 plus 2. So that's negative 32 plus 2. So that's negative 30. Now we take this answer and plug it into Q. Negative 30 is 2 times negative 30 minus 2, which is negative 60 minus 2, which is negative 62. So that is our answer. That is the answer for that. Isn't that great? Same thing's happening down here below. Instead of writing it the way they did here, Q of R of 4, we can also write it with the little O there. That still says Q of R, in this case of 8. This one says R of Q of 8. So the little O, or the other way, is the same way to write these. And we'll show that in a minute. All right. So we have two functions, q and r. Q of x equals x squared plus 9. R of x equals the square root of x plus 8. All right. Oh, they don't ask about domain. Isn't that wonderful? Okay. So in this case, Q of R of 8. So the 8's going to go into the R, and then the R will go into Q. So the 8 goes into the R. So we start with the R. R of 8 equals the square root of 8 plus 8, which is the square root of 16, which is 4. Now we take that and put it into Q. Q of 4 is 4 squared plus 9. 16 plus 9 is 25. So this is 25. Same idea here. R of Q of 8 tells me I'm going to take the 8, put it in the Q, then take the Q, take the Q and put it into R. So we start this time with Q first. Q of 8 equals 8 squared plus 9. That's 64 plus 9, that's 73. Take your 73, plug that now into your R. That's the square root of 73 plus 8, square root of 81, and that's 9. So this equals 9. Notice when you interchange the Q and the R, you do not always get the same answer, right? So be aware of that. Sometimes you do, and those are special when you do. Alrighty, suppose the functions f and g are defined as follows. F of x equals 4 over x when x is not 0. And you can understand why they put that there, right? Because if x is 0, we have 0 in the denominator, and we have troubles. So we always have to specify x cannot be 0. G of x equals x squared minus 7. We want to find the compositions f of g and g of g. So basically what we were doing before was putting numbers in and making life easy. No numbers in this one, but the idea still stands. So we're going to simplify as much as possible. Assume all the expressions are defined for all x in the domain of the composition. You do not, I like that, have to indicate the domain. All right, that's a long problem. Then they gave us a place to write our answers. That was nice of them. So basically, if f is 4 over x, and we're putting that 4 over x into f, f of f is going to be 4 over x, but instead of x, we're putting 4 over x. Well, we know what this is, right? That's 4 over 1 times x over 4, so the answer is x. The answer for that one is x. G of g, it's not so much fun. So it would be x squared minus 7, that's what g is. But we're putting g in where x is, so x squared minus 7 goes in there. I really think, no, it says simplify. Never mind, I was hoping Alex would take the answer. All right. So, oh joy, x squared minus 7 squared. you can FOIL this out and check it. Make sure it's right. It's x to the 4th minus 14x squared plus 49 minus 7. So that's going to be x to the 4th minus 14x squared plus 42. So that's what this one is. X squared. That's a terrible square. X squared minus 14x. No, I'm sorry, it's x to the 4th. X to the 4th minus 14x squared. My pen's acting up. Plus 42. And that's the answer to those. Question 10. We have the function h of x equals the square root of 5x squared plus 6. And we want to find two functions f and g such that f of g of x is going to equal our h of x. And neither function can be the identity function, which means we can't just use x. And there can be more than one correct answer. Previously, we were putting them together to create all these fun things. Now we're going to take it back apart. And the way I'll look at these is what's inside of another function. Well, inside the square root function, you have 5x squared plus 6, which is a quadratic function. So you can let what's inside be g, so that g of x is going to equal 5x squared plus 6. And what's left over for f is your square root function and an x to hold the place. So that's what it's looking for. Always look for what's inside things. Now here comes the fun one. Two functions f and g are defined in the figure below. Your domain of f is 2, 3, 4, 8, and 9. Your range of f is 2, 3, 6, 7, 9. Your domain of g is 0, 2, 6, 7, 9. And the range of g is 3, 7, 8. They want us to find the domain and the range of the composition g of f. Remember, this is going to take f and put it inside g. We want to write the answers in set notation. Watch out for that. All right. Step 1. There's 3 steps. Step 1. Match numbers between the range of f and the domain of g. So this 2 matches that 2. This 6 matches that 6. That 7 matches that 7. That 9 matches that 9. That was fun. Okay. Step 2. Follow matching numbers back to domain. All right, so this 2 comes back to that 9. This 6 comes back to that 4. That 7 comes back to that 8. And that 9 comes back to that 3. So your domain, set notation, so you want to make the set curly brace. It's going to be 3, 4, 8, and 9. For your range, that's step 3. You want to follow the matching numbers to the range. This is the range of G. This was the domain of F. All right, so this 2 goes to that, whoops, that 7. This 6 goes to that 8. That 7 goes to that 7. 9 goes to 8. So the range is only going to be 7 and 8. Notice we can't use interval notation here. That's why they told us to use set notation. Intervals are lines. We keep traveling along, and all the numbers in between them work. This is called discrete. You just have whole numbers going on. There's no intervals. That's why we had to use set notation. Number 12. Oh, 13's a word problem. Yay. All right, number 12. For the real valued functions, g of x equals square root of 3x plus 12, and h of x equals x minus 2, find the composition g of h and specify its domain using interval notation this time. Okay. Notice this is going to be that absolute value v graph. So we got the nice pretty lines on there, so that's why we can have a interval notation. And of course x minus 2 is a line. All right. So let's see if I remember how to do this. G of h of x. Well, they're already in terms of x, so I don't got to think about that part. All right. I just got to take my h, my g function, and plug my h function in to that x, because h is going into g. All right, so g of h equals the square root of 3 times x minus 2 plus 12, which equals the square root of 3x minus 6 plus 12, which is the square root of 3x plus 6. And we're done. That's g of h. Now for the domain of g of h, we have to think about the domain of this, which is 3x plus 12 is greater than or equal to 0. That tells us x is greater than or equal to a negative 4. And we have to think about this for our domain. 3x plus 6 greater than or equal to 0. 3x is greater than or equal to negative 6, so x is greater than or equal to negative 2. All right, so let's graph those two. This one graphs on the line this way. Let's see. Negative 4 will be here. Solid and bigger. It keeps going. Negative 2 would be here. Solid and bigger. Since this part, we want the and. We want the intersection. So the domain is going to be from negative 2 to infinity. Because if you put negative 4 into our g of h, you're going to get a negative radicand, and that won't work. So it has to start at the negative 2. So that's our domain. Alrighty, one more. Word problem. Let's see if we do this. Make sure we don't get it mixed up. Alright, it's blue. Suppose the value R of D dollars in euros is given by R of D equals 8/9 D. The cost P of N in dollars to purchase and ship n purses is given by P of n equals 88n plus 23. Write a formula for the cost Q in euros to purchase and ship n purses. All right, it's not necessary to simplify. Yay, that's important. All right, so basically you have this function that's in dollars, and euros. D is euros. D, these are euros. I'm sorry, D is dollars. I had to reread that. D is dollars. R is euros. Okay. In this one, P is dollars and N is purses. P is dollars, D is dollars. So P is D. P is D. Q is in euros. R is in euros. So Q is actually R of P. It's a composite function. You're going to take the P function and replace it where the D is in R to get Q. So it's 8/9 times 88n plus 23. Isn't that exciting? That concludes homework 9. And if you have any questions, be sure to let me know.